Our next speaker is Dongheui Lee. She is a full professor of autonomous systems at TU Wien in Austria. She is also leading the Human-Centered Assistive Robotics Group at the German Aerospace Center, DLR. Her research interests include human motion understanding, human-robot interaction, machine learning and robotics, and assistive robotics. She was awarded a Carl von Linde Fellowship at the TUM Institute for Advanced Study and a Helmholtz Professorship Prize. Welcome.
Thank you. Yeah, so thank you very much for nice introduction, Nancy, and also inviting me to here to give a talk on the human-centered approaches for robot learning and interaction with the humans. So, what do you envision for the future robotics? A lot of people imagine robots doing a lot of household tasks, some tedious works, and so on. I envision that we can make robots to learn to do this autonomously, these complex tasks, and also we can apply the same learning mechanism to do the human-robot interaction and also assist the humans. So to this end, we have developed different approaches now to do the robot learning for the human demonstrations. We teach the different robots now through the making robot to imitate humans or physical guidances or teleporting robots using the haptic devices or VRs and so on to do various tasks. Like, I think it should come. Yeah, to do some kind of, here some examples, right? Sweeping some trashes, or some hitting a ball to hit another target, making coffee or making cocktails, or robot can able to do some task planning and motion planning, and also robot can do some conditional tasks depending on what kind of objects comes, where to sorting, depending on sometimes about the weight, sometimes it's about depending on the width of the sizes. Yes, but how about the physical human-robot interaction tasks? Can we make robot to learn some physical interaction tasks? So here, then, let's see. It should come, I think. I think it's a bit delay here. So yes, actually we could taught robot to do some physical interaction tasks like here, give me 5 like tasks, right? Here in case robot is now need to understand what action human is doing, and it should infer what interaction types human want to do. Is it low 5 or high 5 or low 10, whatsoever. And then robot should make some physical contact at the right time, at the right places, right? And yeah, so it's good that we can make robot to learn such kind of physical interaction or physical contact making tasks, but also I think I should go on. Next slide. Let's see. Yeah, so beyond of making contact tasks, also we could make robot to do some other type of tasks, like here, joint transportation tasks here. So in this case, what we do is we try to make robot to learn continuously and unsupervised manner how to do this joint transporting tasks. And then we're transforming robot to now learn this task, kind of transforming the robot to make a passive follower at the beginning when the robot doesn't know about the tasks. But while it has experiencing some new data, robot tries to becoming more proactive contributor to these problems. And how we can make a robot to proactive contributor to the task is robot tries now anticipate what kind of path, trajectory human want to go. And using this anticipation, we could make robot to be more proactive in these tasks. Yeah, And also, we could make a robot to do some co-manufacturing tasks here. And human can teach the robot how to do this kind of a fourth level of tasks, like a polishing task. And also, in the middle of the task, it can deal with some unexpected forces given by the humans, and by basically changing some authority levels of between human and robot. So robot is kind of continuously changing in a fully autonomous mode to the kind of shared autonomy mode. It is great that we could see some of the robot learning approaches can be applicable to do this kind of physical interaction tasks, right? In fact, what is great about here is, right, it's kind of a lot of these social traits what human has, right? We like to imitate other persons, and we learn a lot from this, right? This kind of imitation behavior can lead to the make robot to do cognitive interaction and also physical interaction. It is great, but then we have a question, right? Are these existing algorithms and methods are sufficient now to deploy robots in real world, right? I mean, we are all roboticists here, and probably we have all some say maybe similar answers. Probably answer might be no, right? And if we can apply this kind of approaches in the real world, like serving at the cocktail party, and then maybe we imagine that, okay, at the moment we are not really ready yet. And if not, what is so hard about these problems, right? And there are many challenges we have. We have challenges like unstructured dynamic environment, and we have safety issues, a lot of uncertainties are there, and we do not have sufficient robot data to these kind of tasks. And also, more importantly, we have a human in this. And human is a very nice, of course, source of everything making interesting and also complicated, right? And in our opinion, of course, here is making reading why human having is so difficult is, I hope that comes again, the reading human's intention is still largely uninvestigated, right? So now let's talk about the reading humans' intention a bit more in deeper, right? What kind of methodology we have used so far. In the past, we formulated this human intention estimate as either like human activity, recognition, or anticipation for the future, or we forecasting what kind of trajectory human gonna go, or what kind of goal position human want to go, right? But it's all about centered about the humans. But in fact, maybe we should look into a bit this more inside, tries to consider humans in a contextual situation. What kind of situation human is, right? And then based on this information, we should try to infer the human's intention. And here, of course, at the beginning of this kind of research, as a starting point, we basically suggest that, okay, let's look into at least some objects around. So here is we focused at the moment now, okay, what kind of object human attending to? And with that object, what kind of activities human gonna do with it? And maybe that might give us a bit of one step further to understand the human's intention. For that, we formulated now this human intention estimation as detecting and anticipating human object interaction types, and we call here as the HOIs. Basically, we try to look into all the sceneries here and all possible pairs between human and objects and their relationship. It can be a special relationship or it can be activity types and so on. And then hopefully that lead to a bit of better understanding of the human's intention. And as a framework, basically, I'm not going to go into the very details of it here, but at least next slide should come. Yeah, so here, basically we are using a lot of language features and visual features and special features between human and objects and tries to anticipate the human-object interactions in the future. And using this, we try to make robot to becoming more assistive. So here is the example of the human is now approach a kitchen table here. here as the time goes. And then let's look at this point right here. And human is at here, and then recognize now detection point. The system recognize now human is next to the laptop. And then also it anticipates that human gonna be in the future next to the cup. Thus, now at this point, robot is now start to preparing a pouring behavior. So it tries to use some kind of understanding of what is happening in the future, and robot tries to assist in advanced, so that we can try to make more human-robot interaction more fluently, reducing time for the human to wait until the robot start to act on it. So here are some example video clips here, and human is approaching, and robot is now trying to detect it. Okay, human want to drink something, because here in this area there are only possibilities are this kind of drinking water or something, and then now all of a sudden human change the mind, and then humans start to work on now laptops and so on, and the robot now detects that, okay, maybe this assistant is not needed anymore, so robot goes back to the idle pose, and then human is working, and then now again finish the working, and then comes back, and then maybe robot is now start to preparing assistance behaviors for these tasks here. Let's see. Now it grabs the butter, but still waits for confirmation that human want to do it, drink it or not. And then here is kind of we program in a way that, okay, human holds the cup, then we start to pouring a drink for the human. And another example here is also you can see, next video should come. Yeah. So here you can see now human comes now with a cup in a hand. Now robot is now handing over some drink butters, and then now human goes back, and human now packs up everything, and then comes up with now backpack, and then robot is maybe hand over a book. So this is just a starting point of it, just showing some possible proof of concepts, how we can make a robot to be assistive and using anticipation of what human gonna do in the future. Great. So to conclude my talk, so I started about the robot learning from human demonstrations. We start to talk about it. Okay, maybe learning from human demonstration could be applicable for a lot of physical and cognitive human-robot interaction. And especially, I talked a lot about the human intention reading. And we formulated as the activity recognition or motion forecasting, or we try to really look into the human, what kind of contextual information we have it there. And so, but we are still at the early stage of doing this human-centric robot learning and full human-robot interaction. And what is the next? And in my opinion, what is the most important next step would be we need to establish some fundamental mechanisms of intention understanding. And here, this mechanism of intention understanding should be beyond of the data-driven pattern prediction. What we are doing a lot in the current AI is only we look at a lot of things, and then we just guess what's going to be happening more likely using more frequency-based approaches. But it should be beyond of that. And how can we go beyond of that, right? So we should try to infer the goal of the human's action. Why human is doing that behavior now? And if we could infer that goal, then robots should be able to deduce now humans' potential actions and behaviors from the goal given current contextual situation. With that, then robot can infer the human's goal, and robot can deduce what kind of potential tasks planning and motion planning of the human, then robot can assist the humans more effectively. So what I want to conclude here is basically, so this may be having fundamental mechanism of intention might become crucial milestones to reach to more robot-centric, human-centric robot learning and human-robot interaction. Thank you.
So we can take a question or two while we set up our next speaker. We have a question.
Hi, Dongheui. I'm here. This way.
This way, left, yeah.
Yeah, just very nice talk. I just want we're discussing with Wolfram right now. I think the first prediction that the robot should make. I'm working on human-robot interaction for years. I mean, I can say this comfortably, is that humans should be very patient.
Yes. So usually, right, what will happen is a lot of demos what we're doing in the human-robot interaction. Humans are always waiting, right? So I think, first of all, I want to make this fluency much better, right? Human waiting time should be reduced. Then I think we should do the anticipation. In fact, what we are doing is, right, anticipating what's going to be happening in the future. And based on that, we are already plan ahead and act on it so that we can be more synchronized.
Justified, I would say we would change between human-robot interaction to patient-robot interaction.
Yes.
Is there another quick question? I think there's one going to be on the right. I see the microphone moving up the...
Should I?
No, I think
Hi. Please,
Okay.
please.
okay,
Quick enough.
on the left.
I will talk to you
Okay,
later then.
so we'll go in the one up there then.
Okay, can you hear me?
Yes.
So my question is that it's a pre-planned task or random task you are interacting with a human being?
So basically, at the moment, a lot of what we showed here is kind of, we saw that kind of behaviors and robot is learning, right? But then also we kind of have mechanisms to learn autonomously on the fly. So in fact, a lot of things can be go on about the, making new tasks can be learned on the fly because we are doing unsupervised action segmentation and unsupervised motion prediction and activity prediction and so on. And also one of the last things I showed about the human-object interaction part is actually we didn't use any robotic data there. We only used out there videos of the human interacting in the daily life, like some kids are playing a football, and so on. And we could learn a lot of these human-object interactions from the human data, and still applicable, some of the things can be applied to the human-robot interaction cases. Obviously, it is a big question. I'm not going to say that, okay, we do not need robotic data, but we can still also leverage existing human data a lot, and to do it now, to use it for the robotic tasks as well. So, yes.
All right, thank you.
Okay, well, thank you very much.